Welcome to the vCenter Performance Deep Dive Talk. My name is Eric Sachs. I'm one of the engineering directors responsible for vCenter core engineering, and this morning I have the distinct honor of co-presenting with Ravi Soundarajan, who's one of our principal engineers and performance architects. Ravi's been with VMware for, 14 years, Ravi?
Yeah.
I've joined VMware considerably more recently, but between Ravi and I, we probably have somewhere on the order of 30 years of combined performance engineering experience. So we're very happy that you could spend some time with us a little bit this morning. So before we begin, we wanted to highlight that some aspects of this presentation may touch on product features that are currently under development or have not yet been released. The future is unwritten and plans may change, so please keep this disclaimer in mind throughout the presentation. Okay, so our goals for today, we hope that by the time you leave the talk today, you hopefully have a deeper understanding of what vCenter's architecture looks like. What are some of the key components underneath the hood? What do they do and how do they interact? The idea being that with this deeper understanding, that should hopefully provide you with some insights around the kind of factors that can really influence vCenter performance. And then we hope that overall this will be helpful for helping to guide how you actually deploy vCenter, and in cases where you need to track down or investigate some kind of performance issues, that this should also hopefully provide some helpful insights and approaches as well. So we figured it would be good to lead off today by taking a look and sharing some performance data with you that compares the performance of vCenter Windows versus the vCenter Appliance. As some folks may be aware, VMware announced sometime last week plans to deprecate support for Windows in vCenter in an upcoming major release. What this means is that in the next major release of vCenter, support for Windows will still be there, but in releases after that, it may not be. So we figured it would be really good for this talk to share some of the data that Ravi had presented last year that looks at this performance data. And so if you look at what we're showing here, effectively what you see is VC Bench performance. VC Bench is one of our internal benchmarks that we use to characterize and measure vCenter performance. And what you see is performance of VC Bench as run on a cluster of 64 hosts and 8K VMs. And the thing that we see is at a relatively light load of around 140 operations per minute, we see that the performance between Windows and the appliance is actually roughly comparable. But as we begin to increase that load to higher levels, around 400 operations per minute, we begin to see that the performance of the appliance really begins to pull away. And then if we look at even larger scales of around 1,000 hosts and 25,000 VMs, we see that the difference in performance is actually even more significant. And so there's a couple of takeaways that we really want to impress on you as we talk about this. The first of which is we have really focused a lot on making sure that the out-of-the-box performance you see with the vCenter appliance is really good and solid, both across a range of different scales and across a range of different workloads. One of the things that we were able to observe is we were able to bring performance of vCenter on Windows up to something closer to what we could achieve with the appliance with significant operating system tuning of Windows, but this was really fairly difficult to achieve and not something that would be easily obtained out of the box. And so the second thing that we want to hopefully impress with you on is as you look and potentially look to consider to migrating to the appliance, if you have any performance concerns around doing so, we really hope that this data helps put your mind at ease a little bit. Okay, so with that being said, let's spend a little bit of time deep diving into vCenter's architecture. Now, if you think about what a single node deployment of vCenter actually looks like, and you sort of step back and take the 10,000-foot view, the picture that you wind up in your head may not look too dissimilar from this. On one hand, you've got a set of clients that call into vCenter, a server backend, to manage some aspect of your vSphere estate, powering on VMs, powering them off, and so on. And the state of it all is persisted in a backend database. And so the reality is, if you pop open the hood, the reality is actually there's quite a bit more sophistication going on there. And so what we thought it would be useful to do is to actually walk through this with an example. And so for the purposes of this example, what we're going to do is we're going to take a look at a single node deployment of vCenter with an embedded database. And we're going to walk through a very simple example of powering on a VM. So in this case, you have a web browser, your client, which connects to the vCenter server backend. That request is handled by the vSphere client process, which handles all client requests. Now, at this point, your connection isn't authenticated, so the next thing the vSphere client process needs to do is to contact a set of SSO services to authenticate you. SSO will contact Active Directory, and it will also contact the directory service to look up roles and privileges information, effectively to see what it's actually allowed to show you through the UI. Also stored in the directory services is licensing and tagging information. Later on in the presentation, I think Ravi's going to talk a little bit more about the directory service as well. So once it's been established that you've been authenticated, VPXD can now proceed with processing the VM power on request. And in order to do so, the first thing that it needs to do is it knows who you are. It needs to validate that you're actually authorized to do the VM power on. And the other thing that VPXD needs to do is potentially DRS as well. So it's going to look in the database potentially for some information, although in practice, a lot of the information that VPXD needs is also cached in memory. It may also need to contact the storage profile service. And the storage profile service, in turn, will contact VPXD services, which retrieves the storage profile data via key value store front end that is ultimately backed by the database. VPXD services in previous versions of vCenter you may see referred to as the inventory service. It's also responsible for tagging, and it also handles authorization for things that VPXD isn't authoritative around, such as content library. Okay, so finally, once it's been established that all this has happened, VPXD can finally call out to the host to perform your power on operation. So it will do so, and when the host completes, VPXD will get updated information, configuration information about the newly powered on VM via a hosting operation, and then that configuration will be persisted in the database. Now, if you take a look around under the hood, you may notice that there's other services that exist as well. For example, there's a perf chart service that can provide you with a set of overview, real-time, and historical charts. At the same time, there's a set of services such as VMon, which is responsible for automated service restart. There's an HTTP proxy, health checking, content library, and licensing as well. Okay, so when we bring extensions into the mix, extensions such as NSX or vSAN, effectively what happens is when you install the extension, a bit of code gets installed that runs in the context of the vSphere client process. So in this particular example where we're leveraging NSX, what happens is when you want to manage some networking related aspects of your estate, vSphere client will receive the request and it will redirect that to a backend extension server. That extension server may call into other components as well. For example, the ESX agent manager, which in this case is responsible for managing content which is installed on the hosts itself. Okay, so let's take a look at a similar example. In this case, rather than looking on a VM power on example, we're going to look at doing a VM creation. And let's look at sort of the critical path of what this operation looks like across a client, vCenter, and a set of ESXi hosts. So in this particular case, just as before, the client makes the request to vCenter to go and create the VM. vCenter will contact the host to see if the name of the VM that you'd like to create is actually available. Provided it is, the provisioning operation can actually take place. Now, during the provisioning operation, there's obviously quite a bit of I/O that's going to be taking place. You're going to be spending a lot of time within storage. And once that completes, vCenter will get an updated configuration about the newly created VM via a hosting operation. That information will be persisted in the database, and then finally will return back to the client to say that this is all done. So there's a couple of points here that we wanted to highlight. The first of which is that if you look at the overall critical path of this operation, especially for create and clone operations, even though there's a lot of communication taking place between the client and vCenter and the hosts, really a very significant part of the critical path has to do with I/O. So what this means is even in topologies where you happen to have a high latency link and low bandwidth link between vCenter and the hosts, sometimes a topology we refer to as remote office, back office. We want to impress that in cases like this, that's an entirely viable configuration because the reality is a significant portion of that critical path is actually spent doing I/O. So that's something to keep in mind. It is worth pointing out, though, that any optimization you can do to improve the I/O performance of your storage will make a very meaningful difference in the situation. As a matter of fact, in a session we were in yesterday, we had a customer impressed that they've done quite a bit of optimization work around improving the performance of their storage, and they've seen just really, really great results doing that. So that's certainly one thing to highlight. And the other thing we want to highlight is that minimizing the latency that exists between the database and vCenter is also helpful to do, since there's a significant amount of communication that takes place. Okay, so with that being said, I'd like to hand it over to Ravi, who's going to go into more depth in talking about multi-node deployment strategies. Ravi?
Thank you so much, Eric. So Eric gave a great deep dive into what's inside of a vCenter node. I know that a lot of you deploy multi-vCenter environments, so let's talk about some best practices there. And the way I wanted to start was by saying that when most people deploy multiple vCenters, they typically use an external PSC. So let's talk a little bit about what's in vCenter and what's in that external PSC. The external vCenter, which I sometimes call the management node, is basically everything that you just saw and that Eric described, except for shared things like licensing, the directory service, and SSO. And your PSC node is responsible for all of those services when you have a management node and a PSC node separated. I guess I'll pause to take pictures, but let me point out that you'll get the recording and I can send you the slides later. So if you don't get a chance, please don't stress. Okay, so this is the vCenter node and this is the PSC node. So what this actually looks like, we take Eric's beautiful picture and we extract the directory service, we extract licensing, and we extract SSO. And we're left with this sort of a picture, vCenter node and the PSC. And so any operation that would have been done locally within vCenter to SSO, et cetera, now become callouts to this PSC node. And we have caches within vCenter to make sure that you're not always going off node to satisfy these requests. Now, let me show you a hypothetical configuration where you use this. Imagine you have a single PSC. That PSC contains your SSO, and it contains your directory service. Because you have this PSC and the directory service is in a central location, all of your vCenters can take advantage of it and can share it. So of course, now all of your vCenters can share licenses, all of your vCenters can share tags, and all of your vCenters can basically access directory information, et cetera, through this shared service. So now what happens is that you have your web browser and you connect to any one of those vSphere clients processes on one of your vCenters, and now you can see a topology just like what you see right there, where you see a fully federated view in this single SSO domain. So that's really the power of having the PSC in general and having taken some of those services out and letting them be shared. Now let me point out one other important note. As Eric mentioned, tags are stored in the directory service. They're stored in the directory service so that they can be shared across vCenters. So if you have a tag like Windows VMs or Linux VMs, then those tags will be applicable for every single vCenter. But the actual VM or host that it applies to, of course, that's only going to exist in one of those vCenters. So the association between the tag and what it's describing is kept within the vCenter database on the vCenter itself. So what that means is that whenever we do tag operations, we end up doing a bit of communication with the PSC, and then we also consult the database. This is again why, as Eric said, you want to keep your database close to your vCenter. Okay, now it turns out that there is a bit of a problem with this picture. Can anyone tell me what that is? I'll let this gentleman answer. Right, so this is a single point of failure with the PSC. So this is in practice not what you really want to do. Instead, what you want to do is what I'm about to show you. You're going to create a single site and you're going to configure it in PSC HA mode. Now a lot of times people ask me what's a site? And in 6.0 and before, we used to define that as any hosts that have less than 10 milliseconds of latency between them. vCenters and PSCs. In 6.5, we're looking to qualify this so that it can be up to 30 milliseconds per node. Please stay tuned for documentation on that, but that's basically a recommendation. So here's what we recommend. You should have an external load balancer so that you can have failover and so you don't have a single point of failure. And if you're currently in an embedded configuration and you want to move to this external configuration, there are scripts out there that you can look for online that'll let you do the repointing. So you've got your PSCs. Once you connect them in a single site configuration, they're automatically replicating. They replicate within 30 seconds of when a change occurs, so if you ever see temporary differences, that's why. Great, so they automatically replicate. You put the load balancer, And then you have your vCenters talk to the load balancer. This means if any of your PSCs goes down, the other PSC automatically takes over. Okay, so now let's look a little bit about what performance looks like in this topology. So imagine you connect a web browser to one of your vCenters, and imagine you want to search for the string DSL. Okay, now DSL could be, it's just a string that you're looking up. It could be a tag, it could be the name of a host, it could be the name of a cluster, etc. So we basically have to look everywhere to find anything with that string in it. So the first thing the web browser does is talk to the vSphere client process, which then realizes, okay, I got to check to make sure if there's any tags or anything else that's shared with this name. So I'm going to go ahead and forward this request to the load balancer, and one of those PSCs will go ahead and look and then respond. Part one. Part two is that we also have to look locally on this vCenter for anything that might have DSL in it. But we also have to look at all of our peer vCenters to see if any of them have anything with the string DSL. Now, what are the implications of this? If your vCenters have long latency between them, you might be slower in getting your results back. Okay, so just be prepared for that as you run your deployments. In addition, the web browser is talking to one of your vCenters, and it's talking specifically to one of the vSphere client processes. That vSphere client process has to collect all of the results so that it can present them to the web browser. And if that result set is very large, it means you might need more heap size for that vSphere client process than you would if you were not in one of these enhanced linked mode configurations. So when you're looking at sizing heaps, think about how many vCenters you have as you look to deploy that. And I'll help you understand how to look at that a little bit later on. Okay, so this helps you understand latency, and it helps you understand factors that influence the heap. Great, and then it lets you see this view where, as you can see any tag with the name DSL in it, as well as any VMs that have that string. That's a single site configuration. Now let's consider multi-site. So what we recommend for multi-site is if your latencies are greater than 10 milliseconds, and specifically, we recommend that you have no more than 100 milliseconds between multiple vCenters. That's what we're going to use as our definition of a multi-site. We are looking to increase this limit. Again, please stay tuned. Okay? So we're looking to be able to recommend larger latencies for more transcontinental configurations. So your first site looks exactly like what we had in the previous diagram. Your second site looks exactly like what we had in the previous diagram. Again, it's a multi-site configuration. Once you hook them up in a multi-site configuration, you have replication between those sites, but you do not have failover. So if you wanted to have failover, like if both of your PSCs on a site went down, you would have to have an external load balancer between those two sets of sites. Let's take a look at this configuration and look at performance. Imagine you connect a web client and you want to look for something, right? Well, again, you have to look in the PSC because you have to know if it's a tag or if it's something else, and you also have to look at all of your peer vCenters. So you not only send your request to the PSC and to the load balancer, you send the request also to your peer vCenters within your site, and you send the very same request to your peer vCenters across at the other site. Again, let's look at the implications here. The more vCenters, the more you might have to increase the vSphere client process heap because it's going to have to collect results from a lot of different vCenters. The longer the latency, the longer your results are expected to come back. And if one of your vCenters is having issues, it might mean that you might get slower responses. So these are all very important considerations as you plan out your deployment, but this is what we recommend for a multi-site deployment. And it allows you to see an image like this. Now that we've talked about what's inside of a vCenter, and now that we've talked about what we recommend for multi-site deployments, I want to talk about performance considerations. If you've seen this talk in the past, don't worry, it's very different. By the way, if you want more details on Eric's section, you can refer to last year's performance deep dive. So what I'm going to do here is I deal with a number of different performance escalations. So what I'm going to do is walk you through the sorts of things that I do. A lot of times after I do it, I then give feedback to development teams, full stack Eric, and some other folks in the audience that you don't know but are vSphere engineers, and we help try to put these into tools that you can then use. So the first thing I want to point out is that the four things that I typically get asked are, seriously, how many concurrent operations can I actually do? What are the CPU and memory considerations I should be aware of? How do I monitor this database? And is there anything I can do about UI performance? Although in 6.5 it's gotten dramatically better, so hopefully that's less of a concern. Let's go ahead and get started with concurrency. There's 2 hard and fast rules with vCenter overall. vCenter can handle up to 640 or so concurrent tasks before it starts to queue those tasks. It can handle up to 2,000 concurrent sessions before it starts rejecting further login requests. So once you hit 2,000, you can't, no one else can log in. Remember, there's a distinction between a session and a task. I can log in and I can send 600 requests, and that's totally fine. But if 2,000 people try to log in, then at the 2001st, that 2001st person will not be able to log in. Now, those are vCenter-wide limits, but in practice, concurrency is limited by a number of other factors. For example, your host has a limit to the number of operations that it can do. And the way that we like to talk about this is that a host has a fixed number of slots. Once those slots get filled, any operations to that host have to wait. By default, in 6.0, a host has 16 slots. Now, what do operations cost, like the operations Eric talked about with vCbench? If you're a clone, a relocate, or a vMotion, you cost 2 slots. If you are a storage vMotion, you cost 8 slots. We do this because we don't want to overwhelm the host with management operations and then not let the VMs actually do their job. So that's clone, relocate vMotion and storage vMotion. Linked clones are less expensive. Their cost is 1. However, with a linked clone, you have to have a pre-existing snapshot. If a snapshot does not exist, vCenter has to create a snapshot. You can imagine, if you try to do a linked clone with 1 VM, and you try to do, say, 100 of those, each of them is going to have to do a clone. So you're inherently going to serialize that massive set of clones that you're trying to do. Very important. Finally, even if you're cloning a powered-on VM, a similar thing happens. If when you clone a powered-on VM, vCenter creates a temporary snapshot. And so if you try to do 100 of these, it's going to have to do a temporary snapshot before it can let the remainder of the clone complete. Another point of serialization. Okay? Let's take a look at this visually. Suppose I want to clone a VM from host A to host B. That's the extent of my PowerPoint wizardry. And so the cost to host A is 2. The cost to host B is 2. One of them is a source. One of them is a destination. So each of them gets charged. And so then what this looks like is if each of them has 16 slots available, now they each have fewer free slots. So you can take any combination of the operations I showed on the previous slide and fill them up, and once they're done, vCenter will wait on sending operations to that host. Now, very important, what happens if the same host is both the source and the destination? Then, of course, what you're going to see is that the same host gets charged twice, as a source and as a destination. So that host has fewer free slots to do subsequent operations. The reason I bring this up is a very common thing that used to happen, and luckily this has gotten a lot better, is folks would have a large VDI deployment, they'd have a single template, and they'd try to clone that single template across their entire infrastructure. Well, since that single template resides on a host and that's one source, that means you can do up to 8 of those at a time before you have to wait. And so they would try to issue 500 of these clones and see only 8 at a time. And this is why. So very important to understand these. Maybe set up multiple templates, maybe try to spread them across hosts if you want maximum concurrency. Now, those are per host limits, but there are also per data store limits as well. A data store has an available number, has 128 available slots, single data store. So this becomes relevant as you start looking at things like vSAN, for example. So a vMotion costs 1. A storage vMotion is more expensive. It costs 16. So you can do fewer concurrent storage vMotions on a given data store at one time. Those are data store limits. Finally, let's talk about NIC limits. A 1 gig NIC can support up to 4 slots. A 10 gig NIC can support up to 8 slots, so it can do double the number of operations. If you do a vMotion, it costs 1. So you can do 4 concurrent vMotions on a single 1 gig NIC and 8 concurrent vMotions on a 10 gig NIC. Our best practice is for you to create separate NICs or VMK NICs or port groups for a vMotion, and also utilize, it's new in 6.0, but we now allow you to have a vSphere provisioning NIC. So you can send your clone and relocate traffic across one NIC, and you can send your vMotion traffic across another NIC, and this gives you best concurrency on a per NIC basis. I should point out, our primary goal is that if you give us beefy hardware, we try to fully utilize it and make sure the end-to-end latency is fast. Now, in theory, you could change these limits. You could try to issue way more operations at once. But our goal is make each operation faster so that no matter how many, if you issue a fewer number at a time, overall the end-to-end time will still be fast. So if you still have beefier hardware and you find that we're not fully utilizing that hardware, please come talk to us later because we're always trying to look to adaptive ways to refine these limits. Okay? Now, we've talked a lot about concurrent operations, and I hope hope that all makes sense. Now let's talk about CPU and memory monitoring. So here's my rule of thumb. If your CPU of your vCenter server is consistently above 70%, you may want to think about adding more resources. I don't mean occasional peaks. I mean if it's consistently above 70%, then you probably want to probe a little bit deeper and see what's going on. So if it's over 70%, this is the entire vCenter server, check and see which process is taking that CPU. And I'm going to show you how to do this in the next few slides. If that process is VPXD, as Eric said, that's the main business logic as well as DRS, et cetera, you might want to add more CPUs. This also critically depends on what calls are being made. If it is not VPXD, if it is instead one of the Java services that we have inside vCenter, you may need to add more memory to prevent them from doing garbage collection, therefore eating up a lot of CPU. And as I said, and I'll show you how to do this, you may need to examine your plugins and extensions, see what kinds of calls they're making, and see if maybe there's a way to tune that. So that's CPU. I have a similar rule of thumb for memory. If you're consistently above 70% memory usage for your vCenter, you might want to think about adding more memory. This is very important. If your vCenter server starts swapping, you're going to see bad performance. So please prevent it from swapping. And one good way to try to prevent it from swapping at least, is if you're running vCenter in a VM, please make sure to set a reservation on a VM. Actually, we see this a lot where customers don't do this and they end up seeing unpredictable performance, and then once they set the reservation, things stabilize. So please make sure to do that. Oh, sorry, did you want to get that picture there? Okay, I'm going to wait for this guy. Okay, he's done. We're good. Okay, now how do you measure this kind of stuff? In the appliance, it's new in 6.5. We now have this very nice management interface, and if you go to port 5480, you can see a whole bunch of different things. I'm going to focus on the CPU and memory tab. And what you can see here, I'm focusing on CPU. You can see CPU starts to spike at the very end. Generally speaking, if you notice that it's idle for most of the time and then it starts to peak up, you probably are having things going on in your system. That's not bad or anything. It's just, it's good for you to understand the profile of your system. So great. With the appliance in 6.5, you can use this management interface to see what the CPU and memory used is. Now, in case I said earlier, hey, you should check the overall CPU and memory, and then you should see what's taking up CPU and memory. So let's figure out how to do that. Let's start with Windows. Now, all of you that use Windows, and by the way, let me just show of hands. How many are using the Windows vCenter? Okay, and how many are using the appliance? Okay, that's good. Yeah, okay. So we'll start with Windows and then I'll show you the appliance. So in Windows, everybody's used Task Manager, and there's a bit of a wrinkle with using Task Manager, and trust me, this is exactly what I do, so I'm not, I'm totally serious here. Some of our processes have usernames that map to what they actually do. VDCS stands for Content Library, and a lot of our other processes have other meaningful usernames. However, some of our processes, due to limitations with Windows, have just a PID and a username of system. How do you find out what that process is? This is what I do. What I do is that I install Process Explorer. Go and Google it, Mark Rusinovich, one of his tools. And with Process Explorer, I look up the PID of the process that's taking that memory, and then I go ahead and mouse over that process. Now, in Task Manager, you can see the command line, but it's truncated, whereas here you'll see the whole thing. I admit, this is a very unusable way of doing things, but we're constantly improving what we do. So think of this as a stopgap. The point is you mouse over the command line and you see in this case, you can see the location of the log file and it happens to be inventory service. And that tells you, okay, this particular Java service is the inventory service. If you do that for any of your other Java processes, you'll see a similar picture and it'll be similarly easy to figure out which process is consuming that memory. I should point out, in 6.5, we got rid of the inventory service. So this is actually a vCenter 6.0 installation. Instead, we do that in a different way. So that's how you find out what process you're looking at and what's taking CPU in Windows. Let's look at the appliance now. In the appliance, we have this very handy command called vim top. If you're a Linux person, it's like top, but it's specifically for the appliance processes. If you enable troubleshooting mode, and if you enable SSH, you can log into your appliance, type vim top, and you'll see English language names of the various appliance processes. Super, super helpful. I probably use this every single day. It shows you CPU usage. And the way to parse this is that if this says 100%, it means that that service is using 1 core. If it's 200%, it means it's using 2 cores, etc. Okay, so that's CPU. You can also see memory. You can see threads allocated, etc. Okay, so in the appliance, it's actually quite a bit simpler to see exactly which process is consuming resources. Great. Now, where have we come so far? I've said, okay, you should keep track of CPU and memory. You should make sure you're not above 70% all the time. If you are, well, let's go ahead and take a look. Now you know how to look at the CPU, you know how to look at the memory. But I also said it's very important to know what your various plugins and extensions are because they're going to bump up your CPU and memory. So let's take a look at that right now. It turns out in the web client, if you go to the Sessions tab, and this is actually in different locations in 6.0 versus 6.5, but it's there, you can actually enable some columns that are not enabled by default, and they can show you how many API invocations a given session is making. I probably get asked this once a week, and I'm not joking. So it's super useful that this is actually in the client. Now, I do encourage you, as you're installing plugins and extensions, to use names that map to their functionality. For example, I personally installed this plugin before I did this, and now I see it's making a number of calls and I don't know what it is. I mean, I do, it's NSX, but the point is that I didn't at the time that I first looked at that. So let's take a look at a different example. Let's take a look at this one that I've highlighted right here. I've given it the name VRA because it's my vRealize automation instance. And we can see it's making 100-some API calls since this vCenter has been started. Let's find out what those calls are. This is exactly what I do when a customer comes and says, hey, my CPU is really high. This is what I do. So to do this, as I said, this is what I do, and as we learn how to do this internally, we then try to develop tools that will let you do this more easily. So don't be scared if this looks daunting. It will become easier someday. Within your someday, no. And I've got the engineering manager right in the room, so trust me, it'll happen. Okay, so there is a log that's in the same directory as your VPXD log, and it's called the VPXD Profiler log. You may have noticed that it stores information every 5 minutes. This is the location of those logs, both in the Windows and in the appliance. In that log file, it lists the number of sessions. Remember what I said before. If you hit 2,000, then you will not be able to log in anymore. This is what you're looking for. You're looking for that number to hit 2,000, and that's your profiler log, and you're looking in your VPXD log for this error message. The reason I say that is if you hit 2,000, vCenter has some ways of garbage collecting idle sessions. So sometimes just hitting 2,000 isn't enough. You need to look for that error message. If you're hitting that, you are hitting our session limit. Okay? So great. Now, let's look again at this profiler log. Within the profiler log, you not only have a line that says the number of sessions, but for each of your sessions, you also see a line like this. Now, there's a lot of those lines, so scripting is pretty valuable here. In blue, I've highlighted the most important pieces. There is an ID. This is a session ID. There is the username of who's making this call. Super important. That's why you give it human readable names to map to the service. Finally, there's the IP address of whoever's making that request. So you have a service VM somewhere that's making requests. Now you'll know who it is. Let's use this information. We've got the IP, we've got the username, we've got the session ID. Keep that in your memory banks for a little bit. Let's go back and use the VPXD log. It's unfortunate these aren't in the same place, but it's okay. So in the VPXD log, many of your log messages will have a session ID encoded with it. Now you know how to map that session ID to which user it is, simply by looking at the profiler log and looking at your VPXD log. You can see who's making that call. Okay? It not only has that information, it also tells you exactly what call that is. Okay? So armed with this information, I often write scripts, and if you're using Log Insight, you can write scripts there. You can write scripts that can tell you exactly how many calls are made per session, and that'll tell you exactly what your various extensions and plugins are doing. As a matter of fact, I use this very same technique because this call is from my VRA instance, and what is happening is that VRA is doing periodic calls to check what events are happening in vCenter. As a result, it puts a bit of stress on the vCenter database. So if you're using VRA, you probably need to doubly make sure that your vCenter database is properly provisioned. And these things are getting fixed in future releases that, no timeline specified or anything like that. But that's how you can use information like this. You can find out, is somebody making stats calls, is somebody making database calls, is somebody making internal inventory calls, etc. Okay, so let's just take a deep breath for a minute. Okay, that's more for me than for you, but that's cool. Okay, so we've talked about CPU and memory. We've talked about concurrent operations. Now let's talk about the database, okay? So the database is responsible for a lot of stuff. It does rollups. It computes top N, so top 10 by CPU, memory, etc. It does those in scheduled jobs. As Eric mentioned, whenever vCenter sends an operation to a host, the host completes, tells vCenter that the operation is done. vCenter issues what's called a host sync so that it can get synchronized with the state of that host. And that information is persisted to the database. And if you do stats queries, or if you do event queries, or whenever you execute a task, your database is invoked. Okay, this is why Eric said that you should keep your vCenter and your database close together if possible. So let's talk about database performance profiling. First thing I want to point out, the database is very write intensive. Forgetting about all of your extensions and plugins and just focusing on vCenter itself, you do a lot of writes to your transaction log because of course we want to be able to roll back. You do a lot of writes to your core inventory tables, when you edit a VM, edit a host, etc. And you do a lot of writes to the so-called seat tables, stats, events, alarms, and tasks. Given that these particular tables and partitions are so heavily trafficked with writes, it's very important to put them on low latency, high bandwidth storage, SSDs, if that's an option. Okay, and maybe if you're using SQL, you can use different table spaces and put things on different partitions to make sure that you have very good write bandwidth. If you see slow API calls, you've got some plugin or extension or you're logging in and things seem to be slow, a good thing to do is to check your database resources. Check your CPU, check your memory. I'm going to show you how to do this in the following slides. Another thing you definitely want to do, please make sure that you don't run out of database space. If you do, vCenter will crash. So I will show you how to do this in a little bit as well, but these are super, super important to do. Now regarding checking database space, please use the vCenter alarm that exists that tells you whether you're running out of space. I will show you how to do this in a few slides, but please take advantage of that particular alarm. I hate to keep saying that, but honestly, I kind of just want to make sure you know where I'm going with this talk. There is a very nice, I showed you the VAMI earlier, the appliance management interface to show you CPU usage on the appliance. It's also got a very nice tab for database utilization. I'm going to show you a screenshot of that in a moment. Okay? If you start running out of space, sometimes you're asked to reduce the retention time of tasks and events. I'm going to show you how to look at what tasks and events are in your database so you know if you need to reduce it or not, and if so, what's actually causing all of that traffic. Sometimes we ask you to lower your stats level. The default is 1, which is fine. You can increase it, and that's great, but sometimes we ask you to throttle it back in case the database is getting filled with stats. And sometimes GSS will actually ask you to truncate some tables if it's running out of space and causing your queries to be slow. Okay? So let's take a look at each of these in turn. First, let's start with the appliance management interface. Again, this is new in 6.5, but you can basically see the breakdown. In this case, you can see that the transaction log is taking the bulk of the space in the database. And you can also see breakdown by these stats, tasks, stats, events, alarms, and task tables. So this is a great way for you to monitor what the appliance utilization is. And there's actually an API to get this. We can give you more details about that later on. We can get that offline. Okay, so that's the appliance management interface. And you can see, as I said before, that the transaction log and then stats, events, and tasks and alarms tend to be the largest consumers of space. So make sure that they have a lot of space. Now, if you're a Linux person or using the appliance, you all know that you can use the command line. You can use df, and df is going to show you how much each partition is taking up. And I've highlighted the very same partitions that I just showed you in the previous slide. So if you sort of want more detailed numbers, this is how you might do that. You can also see the storage core partition, and that's where core files are kept in case anytime you get a core dump, etc. So good information on the appliance. Now, I mentioned a database space utilization alarm. Here it is. This alarm will fire a warning at 80%, and it will stop VPXD at 90%. You can change these. It's an advanced setting. I can tell you more about that offline. Please use this, because if your database crashes and you can't log into vCenter, you can't get any of the information that you need. So I strongly recommend you use this. Great. Now, there's also general health of services that you can see in things like the web client. And what I want to highlight here is for the database, you can also look and see things like the fact that in this particular setup that I had, my roll-ups weren't occurring from past week to past month. If roll-ups don't occur, your stats tables get very big, your stats queries get slow. That's not a good thing. So you definitely want to keep track of these things as well. Okay, I said we should make sure to keep track of what's in the database. Let me show you how. If you're using the client, you can look at events by looking in the UI. Now, this is a bit of a limited view, so if you want a larger view, I would recommend you use Power CLI and use the getVI event command. Okay, this is, again, a limited view. Let me show you what I do. I often look directly at the database. This is not technically supported for customers, but we are looking at ways to expose this very information. So as I discover these things, I give folks feedback and we put this sort of stuff in. So if you want more detail than what this script shows or what this UI shows, your database admin will know how to do this for SQL. And in SQL, you simply open up the management interface, and I show you two very simple SQL statements. The first one shows you all of the total number of events. The second one groups those events by how many of them there are. And you can see in this profile that the top two events are logins and logouts. This is pretty much what I see in virtually every customer setup I see. Why? Because customers have extensions and plugins that log into vCenter periodically, and sometimes they have tools that log in individually to each ESX host using the API. Whenever you log into a host using the API, you generate an event. And so if you're in a position where you're writing scripts where you need to figure out, should I go to the host or go to vCenter, I would recommend getting that information from vCenter wherever possible so you don't fill your database with login and logout requests. By the way, please log out. If you don't, that's not a good thing either. Okay, if you want to get the very same information using the appliance, it's practically the same thing. You SSH into the appliance and you issue this command. I give the command line right there, and like I said, I will share these slides afterward in case you don't have time to copy it. But line number 2 logs you in. Line number 3, you just do exactly what I show in that picture up there. And you can get exactly the same information from the appliance. Again, we're looking to build these features into the various management interfaces so you won't have to do this. I'm just telling you what I do. Okay? Oh, and one final thing I should point out. With many customers that I look at, when their database is growing beyond 100 million rows for, say, events, that's when I start to look and say, okay, we definitely have to keep good track of how much space you're taking up and what your IOPS are looking at. Typically, 100 million is the place where I start to see, I don't start to see issues, but it's where I start to take special care. So you might want to monitor the sizes of your database for that sort of thing. Okay? Now, I mentioned earlier that, okay, watch out for events, watch out for tasks, watch out for stats level. Let me quickly show you what happens when you change the stats level. Here's 3 configurations. 2 of them are VMs, and the only thing that's changed is the number of disks. And then there's a host. It's obviously got more cores, etc. When you change the stats level, the biggest jump occurs from stats level 1 to stats level 2. This is a script that I wrote. I can maybe release it if people care. But the point is, when you go from stats level 1 to stats level 2, you enable a lot of data store and network stats. And you can see that because the first VM has more disks than the second one, that's why its jump is quite a bit higher. Okay? So plan this out as you're planning your infrastructure. If some tool is telling you, increase your stats level, first of all, talk to me because they shouldn't be doing that. But secondly, if they are, make sure to plan for how much extra capacity you'll need. And it's important to reach out to us because sometimes we put stats at various stats levels for a reason. And if we find that many customers aren't getting what they need at the right level, maybe we can look into changing that. Okay? So take up from this slide is now you know what the impact of stats levels are. Great. Now, if you want to get even deeper into what's happening with the database, you can use, in SQL, you can use the SQL Profiler. I often do this if I have a customer that says, you know, my CPU on my database is really high, or my memory usage is really high, what's going on? I enable a tool called the SQL Profiler. Again, your DBA will know what that is, and if he doesn't, I can give you instructions later. And this SQL Profiler allows you to set a trace where you can see exactly what's going on. And what I look for is I look for the CPU usage. Again, that's in terms of percent, so 141% is 1.4 cores. And then I look at the number of reads and the number of writes. If those numbers are really high, you might want to take a look at what that transaction is and figure out if it's written properly. Now, if it's written by us, then there's not much that you can do, but you can at least be aware of it and know what's happening, and maybe that's a call to GSS. If it's a partner tool, you might want to engage with that partner to find out what is this doing and are we sure that we've optimized this. This is exactly what I do, and I use this to find bugs. Well, bugs is perhaps not the right word, but I use this to find issues occasionally. This is what I do when I'm dealing with a SQL server. If I am dealing with the appliance, I can do a very similar thing. Okay? There is a command, I give it at the very top, PG top. It shows you a very nice, I don't know how you would describe that, curses-based interface, a very nice interface that shows you what's going on in your database. Typically speaking, with the appliance, your database will show periodic peaks every so often because it's doing cleanup. It should not be sustained at 100%. If your database is always at 100% utilization, that's cause for you to look in and find out what's going on, or it's cause for a GSS call. So let's look at what this looks like. So this particular line, you can see that the very end of the line says declare cursor. When you see things like this, those are almost always queries to our stats database. If you want to know more, you find the PID, it's in the line, and then you hit capital Q, and you can find out exactly what query that is. So you notice you're doing exactly the same thing that you were doing in SQL, just a slightly different interface. And if you want to get the same reads and write stats, you hit capital R. Okay, that'll show you reads, it'll show you writes, and it'll show you inserts. This is super valuable for me. When I look at this, I can then say, okay, I now know what's going on in your database. You might also see lines like this with the phrase auto vacuum. Auto vacuum is the embedded database's way of doing periodic maintenance. Okay, so you will occasionally see that go to 100%, but it shouldn't be sustained. If it is, you may have some sort of disk corruption. So this is an important thing to look at. Okay, not alarming if it occasionally goes up, but it will be alarming if it stays there for minutes at a time. Okay. Now, if you want to look at logs and get a very high level, we've looked pretty deeply into the database. Let's take a step back up. If you see lines like this, SQL execution took too long, that means that there are some slow things with respect to the database. If you see things that are occasionally 3 to 4 seconds, that's typically not alarming. We expect that, and we especially expect that with stats queries, and we especially expect that with event queries or top-end queries. The log line will tell you what table it is, so you can figure that out. If you see really, really frequent 3 to 4 second queries, that's typically a bad sign, except, for example, for stats and events. So really frequent 3 to 4 seconds is when you start thinking, maybe I should look at my database and make sure that it's performing okay. If you see queries that are greater than 10 seconds, that is usually bad, and it usually means we have to look and see, maybe if you're running on SQL, maybe you have to initiate a recomputing of the database engine stats. Now, again, if you have slow queries, I've already mentioned this, you might have to, with the help of GSS, truncate your tables, you might have to lower your retention policy, you might even have to lower your stats level. There's a lot of different things that we can do to help with this situation. And again, please make sure that your log, database log, your inventory partition, and your seat tables are on fast storage. Okay, we're almost done. Next to the last slide. Let's talk about UI performance. Actually, not quite next to last, but whatever. One of the most important things for web client performance is heap size, and I'm going to show you how to look at that in a minute. So, as I said, the more vCenters you have, you now know that a single vSphere client might have to marshal up responses from various vCenters, so you might have to increase the heap. If you have multiple clients, you might have to increase the heap for the same reason, because it's servicing requests from multiple sources. If you have a really large inventory, there's more result sets on your searches, you might need more memory. I should also point out that as you install extensions, you might also increase memory. And often what I do is I might increase my vSphere client by about 1 gig to accommodate large inventories and lots of extensions. Just to avoid having it ask you whether you want to accept a certificate or not, I would load certificates into the browser. The memory and CPU of the machine running your browser is very important. Please give it at least 2 vCPU and 4 gig. If it's only 1 vCPU, you're going to see very slow latencies for your client requests. If you have the option, I know that sometimes you have to use the client over a VPN or something. If you can maybe go into a jump box that's within the same LAN segment as your vCenter, and then use the client from there, that will sometimes give you better performance. And finally, as Eric pointed out, when you install plugins and extensions, you not only install a little bit of code inside a vSphere client, but you also end up making callouts to an extension server. So try to make sure that that extension server is close to your vCenter server. To detect heap issues, this is what I do. I again look at Vim top, and I look at CPU and memory. If your CPU is very high, and if it's very high for long periods of time, what I will sometimes then do is look at the command cloud VM RAM size -L. What this shows me is the desired allocation for each of my services. Now, what's in cloud VM RAM size will often be slightly less than what you see in practice because of data that's shared from multiple processes. But the point is that if those two numbers are very close, and if your CPU is really high, you probably need to increase your heap size. And so in this particular case, I kind of did it just for the purposes of illustration. I lowered the heap. But if you were to increase the heap, you would see CPU go down and you'd get much better responsiveness. So this is a good way to check that. And if you have to increase the size of your heap, the command is cloud VM RAM size -C. I've got it right down there. It's available in the appliance just on the command line. If you're in Windows, it's in this path right here. OK? I don't see any other cameras, so I'm going to go to the very last slide. OK. Oh, sorry, man. OK, to conclude. We hope that we've convinced you that vCenter appliance performance meets or exceeds Windows, so hopefully performance isn't a barrier to going to the appliance. We hope we've articulated that your load, your inventory size, number of clients, et cetera, these are all considerations as you plan out the resources that you need. And I hope I've convinced you that the appliance, while it may be a different set of interfaces, it does offer a very rich set of debugging tools, so we encourage you to try those out. With that, I just want to point out there's a lot of other great talks by my colleagues in the performance group. I would encourage you to see them or see the recording. I would also like to encourage you to go and try these hands-on labs. And in our group, we like to get feedback on the talks that we're giving. So this is separate from the standard VMworld survey. But if you have time, either do your thing with your phone or go to that go/perf line. With this, I'm going to ask you to fill out your VMworld survey, and we're happy to take questions. And whatever we can't get to here, I'll stand outside, and feel free to come find us out there. Thank you very much for being so attentive. Very much appreciated.